Download this code from codegive.com, link in the description below. Automating IT disaster recovery plans using runbooks is a critical step in ensuring that organizations are prepared for unexpected outages or disasters. Runbooks provide a structured approach to executing recovery operations and can be automated using various tools and scripting languages. Below is a comprehensive tutorial on how to automate IT disaster recovery plans with runbooks, complete with code examples. Step 1. Define your disaster recovery plan. Before you begin automating, it's essential to have a clear disaster recovery (DR) plan. This plan should include 1. Recovery objectives. Recovery time objective, RTO, the maximum acceptable time to restore services. Recovery point objective, RPO, the maximum acceptable amount of data loss measured in time. 2. Critical systems, identify which systems are critical to your business operations. 3. Recovery procedures, document the procedures required to recover systems. 4. Roles and responsibilities, clearly define who is responsible for each step in the recovery process. Step 2. Create a runbook. A runbook is essentially a compilation of procedures and operations that are needed to recover from a disaster. Here's a simple structure for a runbook. Title: Runbook for system name. Purpose: brief description of what this runbook covers. Prerequisites: any conditions that must be met before executing the runbook. Steps: detailed instructions for recovery. Example runbook structure. YAML. Runbook for MySQL database recovery. Title: MySQL database recovery. Purpose: restore MySQL database from backup. Prerequisites: access to backup storage. MySQL installed. Steps. Step 1. Stop MySQL service. Step 2. Backup existing database. Step 3. Restore database from backup. Step 4. Start MySQL service. Step 3. Choose automation tools. Several tools can help automate runbooks, such as AWS Lambda, for serverless automation. Azure Automation, for managing Azure resources. Terraform, for infrastructure as code. Ansible, for configuration management and application deployment. Step 4, automation with code examples. Example: automating MySQL database recovery using Bash script. Here's an example of a simple Bash script that automates the recovery of a MySQL database. Bash /bin/bash. Variables. Backup_dir equals /path/to/backup. DB_name equals my_database. MySQL_user equals root. MySQL_pass equals your_password. Step 1. Stop MySQL service. Echo stopping MySQL service. Sudo systemctl stop MySQL. Step 2. Backup existing database. Echo backing up existing database. Miscldump $$user-p$mysql_pass $db_name $backup_dir/backup_$, date plus %f, .sql. Step 3. Restore database from backup. Echo restoring database from backup. MySQL $mysql_user-p $mysql_pass $db_name $backup_dir/backup_to_restore.sql. Step 4. Start MySQL service. Echo starting MySQL service. Sudo systemctl start MySQL. Echo MySQL database recovery completed. Step 5, Testing your runbook. 1. Simulate a disaster. Perform a test by simulating a disaster and executing the runbook. 2. Document results. Note any issues encountered during the execution. 3. Refine the runbook. Update the runbook based on your testing experience. Step 6, Schedule and monitor. 1. Schedule regular tests. Set up a regular schedule to test your runbooks. 2. Monitor execution. Use monitoring tools to ensure that the automation works as intended and send alerts for failures. Conclusion: automating IT disaster recovery plans using runbooks can significantly reduce the time and effort required to recover from a disaster. By following the steps outlined in this tutorial, you can create a robust, efficient, and reliable disaster recovery process. Always remember to keep your runbooks updated and conduct regular testing to ensure their effectiveness. Automating IT disaster recovery (DR) plans is crucial for minimizing downtime and ensuring business continuity. Runbooks are a fundamental part of this process, providing step-by-step instructions for recovery tasks. In this tutorial, we'll cover the basics of creating automated DR plans using runbooks, and I'll provide a simple code example using Python and AWS Lambda for automation. What is a runbook? A runbook is a set of standardized procedures and operations that are followed during an IT incident, including disaster recovery scenarios. It typically includes prerequisites * what needs to be in place before the runbook can be executed. Step-by-step instructions * detailed tasks to carry out. Post-recovery verification * steps to ensure the recovery was successful. Roles and responsibilities * who is responsible for what during the execution of the runbook. Steps to automate IT disaster recovery plans. 1. Define your disaster recovery strategy. Identify critical systems and applications. Establish recovery time objectives, RTO, and recovery point objectives, RPO. Determine the recovery strategy, backup, failover, etc. 2. Create runbooks. Write clear and concise runbooks for each recovery scenario. Include all necessary details to execute the recovery plan. 3. Choose automation tools. Use tools like AWS Lambda, Azure Functions, or other orchestration platforms. Consider using infrastructure as code, IAC, tools like Terraform or CloudFormation. 4. Implement the automation. Write scripts or code to execute the steps defined in the runbook. Use APIs provided by cloud services for automation. 5. Test the automation. Regularly test your automated runbooks to ensure they work as intended. Update them as necessary to adapt to changes in your environment. 6. Monitor and improve. Implement monitoring to detect failures or issues. Continuously refine the runbooks based on test results and incidents. Example: automating disaster recovery with AWS Lambda. In this example, we will create a simple AWS Lambda function to automate the recovery of an EC2 instance, assuming that it requires stopping an instance, creating an AMI, Amazon Machine Image, and launching a new instance from that AMI. Step 1, Prerequisites. An AWS account. AWS CLI configured with appropriate permissions. An EC2 instance that can be used for demonstration. Step 2, Write the Lambda function. Below is a simple Python script that can be used as an AWS Lambda function to automate the recovery process. Python. Import Boto3. Import time. Def lambda _handler, event, context. EC2 equals Boto3.client, EC2. Define the instance ID to recover. instance underscore ID equals I0 ABCD 1234 F5678 replace with your instance ID. Try. Stop the instance. Print, F stopping instance, instance underscore ID. EC2.stop underscore instances, instances equals instance underscore ID. Wait underscore for underscore instance underscore state, EC2, instance underscore ID, stopped. Create an AMI. Print, F creating AMI for instance, instance underscore ID. AMI underscore response equals EC2.create underscore image, instance ID equals instance underscore ID, name equals backup AMI, no reboot equals true. AMI underscore ID equals AMI underscore response image ID. Print, F AMI created, AMI underscore ID. Wait for AMI to become available. Wait underscore for underscore AMI underscore state, EC2, AMI underscore ID. Launch a new instance from the AMI. Print, F launching new instance from AMI, AMI underscore ID. New underscore instance equals EC2.run underscore instances, image ID equals AMI underscore ID, min count equals 1, max count equals 1, instance type equals T2.micro. New underscore instance underscore ID equals new underscore instance instances 0 instance ID. Print, F new instance launched, new underscore instance underscore ID. Return. Status code, 200. Body, F recovery completed, new instance ID is new underscore instance underscore ID. Accept exception as E. Return. Status code, 500. Body, str, E. Def wait underscore for underscore instance underscore state, EC2, instance underscore ID, state. Print, F waiting for instance underscore ID to be state. Waiter equals EC2.get underscore waiter, F instance underscore state. Waiter.wait, instances equals instance underscore ID. Print, F instance underscore ID is now state dot. Def wait underscore for underscore AMI underscore state, EC2, AMI underscore ID. Print, F waiting for AMI underscore ID to become available. Waiter equals EC2.get underscore waiter, image underscore available. Waiter.wait, filters equals name, image ID, values, AMI underscore ID. Print, F AMI underscore ID is now available. Step 3, deploy the Lambda function. 1. Create a new Lambda function in the AWS Management Console. 2. Configure the Lambda function with the necessary IAM role that has permissions to manage EC2 instances and AMIS. 3. Copy the above code into the Lambda function's code editor. 4. Set the necessary environment variables or hardcode values, like instance IDs, as needed. Step 4, test your automation. Trigger the Lambda function manually or set up an event, like a CloudWatch alarm, to trigger it automatically based on certain conditions. Step 5, monitor and review. Monitor the execution of the Lambda function using AWS CloudWatch logs. Regularly review and update your runbook and automation scripts to ensure they are effective. Conclusion. Automating IT disaster recovery plans using runbooks can significantly reduce recovery time and improve organizational resilience. By following the steps outlined in this tutorial and using the provided code example, you can establish a reliable and automated DR process tailored to your environment. Regularly testing and updating your runbooks is essential to ensure they remain effective in real-world scenarios.